Hi guys, welcome to the explanation part of the quiz, and a very big congratulations to Samriddhi, Quiet Time TV, Natasha, Tanmay, Vignan, and Arpit, who are the top six contestants today. Like, who really did a great job in the quiz. So, really happy to see you guys doing so well. And now we are gonna start with the explanation part of this quiz. Okay, so and again, this is not gonna be a general explanation session that I'm gonna just tell you, okay, which questions, how to solve, and all of that. But I'm gonna focus more on better methods as well. So a quick intro about me. I'm Piyush. I'm your co-host, I'm main host for this part of the session. I'm from GMAT Quiz, one of the founders of GMAT Quiz. I have 10 years of experience mentoring students who are targeting top tier B schools across the globe. I've prepared and taught for both GMAT and CAT. Personally scored a 740 on the GMAT, 99.9 on CAT, and I love analyzing trends and data. And I'm a quant and DI expert, as I say. So that's a quick intro, very quick intro about myself. We will jump into the first three questions. The first three questions are like uh, easy to very easy, very easy to easy questions. So I'm not going to spend a lot of time on those. I'm going to spend most of my time on the next seven questions, and most of the key learnings are going to come from there. But still, we're going to go through each of these questions. So first one, it's a time and distance question. Very simple in most of the time and distance questions. If it's a simple question, we recommend you use the DST table, distance, speed, time table. Just makes your life so very easy. And again, guys, this is more for beginners. If you're just starting doing DST, you need to draw this table. Just puts more structure into question solving, nothing else. At this stage, right now, I don't use DST at all. Like, I don't have to really chart everything down in this table, and I don't recommend most of my advanced stage students to do that either. Yes, Yuvanshu says B. I think that was the right answer for the last question. But yes, you're a little late for that. But we are right now discussing the first question explanation. So let's focus on that, guys. So I see that the first part of the journey, the distance was 150 miles. I just put the detail over here. 50 miles per hour is the speed, so time will be 3. Second part of the journey, 80 miles was the distance. Basically, 40 miles per hour was the speed. 2 is the time. So obviously, I can add the times. That's the only thing I can add apart from the distance. So if I add both of them, and the question is asking me for the average speed will be 230 by 5, which is 46 kilometers, oh sorry, miles per hour in this particular case. Okay, so again, I have not read the question in front of you as I would generally do in the first go explaining the solution, because you guys have done this just half an hour back, right? That's what when it started. So it will be still fresh in your mind. A fairly straightforward question, nothing too complicated to deal with. If you use the DST table, just plug in the values at the right place, you'll be able to get this. I hope none of you have a doubt related to this. So I'm moving to the next question. Now, this is a question on time and work. You can say that, or you can say general arithmetic problem as well. A word problem basically. If you look at this, says that the general rate, hourly rate, wage rather of the basically the employee, the general hourly wage is $5.50, and his overtime rate is basically 1.5 times of this. So you just have to do this math, simple math, which can be done in 5.6 plus half of that. You can do it like that instead of doing the multiplication, slightly better. And he works for 8 hours overtime. So to get the number of like hours, it is you don't have to even worry about that either. So overtime hours is 8 hours. What is the total money that he makes in overtime? So you just have to multiply these two. Honestly, I did not even did this multiplication. I said 8 eights are 64, right? So the answer has to be more than 64. And the only option which was more than 64 was 67.2. So do say a yes in the chat if you also did the same thing. Instead of doing the multiplication, you said 8 into 8 is 64. Only answer which is more than 64 is A, and I'm good. I don't have to do the exact math. If you did that same thing when you were solving the question yourself, do say yes. I would like to see that, guys. So again, this is what is called as awareness, and I'll talk more about this as we move forward. So again, another fairly simple, straightforward question. Nothing complicated about the question. Let's look at the first data sufficiency question. Again, just for your information, data sufficiency questions are generally nowadays it's a part of data insights, but they're generally coming from word problems, statistics, and some logic-based problems as well. So this will still feature in the GMAT, but in the DI section, guys. So still important. Okay. I see Sriharsha, Huful, and Vignan saying I did that. Kudos to you guys. I'm really happy to see that you guys actually identified that you don't need to kind of calculate the exact value. Natasha says I did not do it. So Natasha, that's a learning for you and maybe some other people also. So thank you so much for the responses. Let's get into this. So I see the question is asking me, it's telling me that basically some wet is there, some vessel, let's call it. If I don't understand what wet is, you don't have to worry about it. I also did not know the meaning of the word wet. That's okay. But I understand that there's some vessel in which milk is being pumped. So there's milk going in through a pipe. You can draw a pipe if you want to. And there is milk coming out from another pipe. Okay, so there's another pipe from which milk is coming out. And it says at what rate is the amount of the milk in the vat decreasing. So in simple terms, if I do some bit of rethinking, and pre-analysis is very critical in DS. So what I understand is I need to know the outflow rate, I need to know the inflow rate. If I know both the rates, I can subtract it, and that's what my answer is going to be. So when you do this pre-analysis in a DS question, this is gonna help you get to the answer in the least possible time. Okay, you don't need to do a lot of math. Just do this pre-analysis. Sometimes you might need to do a bit of math in pre-analysis. Also depends on question to question, and I'll show you an example of that today as well. But if you do this right, you sometimes just need to read the statement and you have your answer. So if I look at the first one, it says amount of milk initially in the vat was 100 liters. Now, what this is a trap. This is what I call as a trap choice. Again, trap statement. It says amount of milk. I don't care about how much milk is left at a particular point. I'm only talking about the rate at which it is decreasing. So if I'm only focused on the rate at which it is decreasing, I don't really care about how much milk was there. So this is not going to help me in any case. I can just ignore the statement. Now, if I go to the next statement, it tells me the inflow rate, it tells me the outflow rate. If I know the inflow rate, I know the outflow rate, I can answer the question. I don't really need to do the math and find exactly how many liters per minute are actually going out. I don't have to do the math at all. I just need to know both the pieces of information, and my answer, my question is answered. So the answer to this one is option B, which is statement 2 alone is sufficient to answer the question. Okay, guys. So again, these were the simpler questions. Now we will get to the more medium and then the more harder questions. But before I get to that, I want you to understand something very, very important, because I'm not here to just add value in terms of how you can solve these questions, but I want you to understand how to increase your quant score in general. So if you notice, the quant scoring has changed a lot in the old GMAT and the new GMAT, which is the GMAT Focus edition. And a lot of people have not adapted their strategies based on the new GMAT version, because the new GMAT version requires you to have a very different type of skill in quant compared to the previous one. Now, why do I say so? Some of you might be thinking, what's going on? Like, only some topics have been removed. What else has changed? Let me explain that to you guys. So what used to happen in the previous GMAT was, in the old GMAT, which was there till almost 1.5 years back, the quant 49, if someone was at a quant 49, which was a 73rd percentile score, those of you who don't remember that portion, those of you who don't remember that, 73rd percentile, if you jump to the highest score, which was a quant 51, okay, that used to get you a 20-point bump in your overall score. So let's say if you were at a 600, you would get to a 620 by improving from 49 to 51. Okay. Now, why am I telling you this? Because earlier, it didn't make a lot of sense to put in a lot of effort on quant, because that 20-point jump required you to put a lot of hard work to move from 73rd percentile to 100th percentile on the quant, basically. So there was a lot of effort needed for that 20-point jump. But now with the GMAT Focus, if you notice, this is a table from MBA.com, guys. It shows the percentile mapping of quant. You can see, guys, quant 82 is the 76th percentile score. Now, if you improve from a quant 82 to a quant 90, which is the 100th percentile, earlier there were just 2 points improvement scope was there. Now there is 8 points, basically. So what they have done is they have increased the number of scores that people can get between the 2 percentiles. So in terms of difficulty level, 76th percentile is same as 73rd percentile earlier. Similar type of people will get there. But now you can actually get to, earlier if people were going from 49 directly to 50, they were possibly, you can compare it with like going from 82 to 86. If you don't get to 86, like you were not getting any additional extra score. But now there are so many intervals in between where you can actually land up and increase your score more. So in very simple terms, if I put it, if you go from 82 to 90 now in quant, you can get a 60-point bump in your score. So it's same as saying basically if you are at a, let's say 690, you can get to a 750 kind of a number just because of quant. Now, why this is important? This is, can anyone tell me why is this important? What are you understanding from this? Because earlier, the same kind of jump in percentile require just got you 20 points extra, but now it gets you 60 point extra. So it does make sense for you to put in an extra effort, because every step that you put in can yield you a significant additional advantage in quant. Now, why that matters is because now the key to scoring 99th percentile, like 99th percentile or even any percentile in close to that, is going to give you a higher score. So it does make sense for you to basically put in the extra effort. Now, earlier people did not used to learn a lot of great methods or smarter methods, but if you want to do that now, you need to have conceptual clarity. Just knowing basic concepts won't help. You need to learn smarter logical methods of solving questions so that you're able to do them faster and actually be able to score higher. And same thing, you also need to have a lot more awareness. Earlier, if you did not have these skills, possibly instead of a 51, you landed at a 50, it hurted your score by just 10 points. Okay, that's the way, I think, the way to look at it. So if you just went from a 51 to 50, it hurted your score by 10 points. If you went another level down, it hurted your score by 20 points. But now, if you're at a quant 90 level, if you like, let's say, get to a quant 50 level, which is like 86, it hurts your score by around 40 points, 30 to 40 points. Okay, that's the kind of change I'm talking about. Yes, every extra question increases your chances of getting an admit. Great point, Manish. That's one of the best ways to kind of summarize that. So all these three things are very critical. So why I'm telling about this is because I want you guys to understand the importance of this. And I'm going to tell you some of the smarter methods. And obviously, when I tell you these methods, I can't teach you all in that very quick, short 40-50 minute session. But I'm going to try my best to help you understand some of these things. At least you can start thinking around this. Now, what is awareness specifically? Some people understand smarter logical methods, but what is awareness? Awareness is about being aware about the question, the options, everything that is happening around you, and taking different paths in different scenarios, not necessarily the same path always. Like when I work with my students at GMAT Quiz, I ensure that I look at their awareness levels, I look at their methods, I look at their conceptual clarity, and we work on all three areas. And that's when you get to the perfect score of 90, 88, those kind of scores. You only get there if you work on all three things. So very important to do that. So let's talk a little bit about the smarter method. So if you look at quant, okay, this guy has scored a quant 87, but if you see, he has taken 7.7 minutes in a question, 4 minutes on another question, but he was still able to get to that score because he actually did a lot of questions under 1.5 minutes. So what you need to also understand is that some questions in the test, even for the best of the best students, whether it's about quant or DI, will take you extra time. Here you can see the student has spent 4 minutes, 5 minutes on a few questions, but still she was able to do well because of the time that she took on, lesser time that she took on the other questions. So what smarter methods allow you to do is, they allow you to save time from questions which are within your control. And if you learn those methods, they can possibly save 20-30 seconds on one of the questions, each of the questions. And if you accumulate those 20 seconds from each of the questions, and you can do that even in 10 questions, you still save 200 seconds, which is easily 3 minutes. And some of the methods are so good that you can easily save 1.5 minutes, even 2 minutes on a few questions. So even if you get 2 of those questions or 3 of those questions in the test, you have 5 or 6 minutes extra over another student. Imagine the impact that it can create. Okay, now that is what you need to do, and every small thing matters, guys. So one of the applications we will see in this particular question, again, not a very tough question, a simple question, but what we need to understand here is there are multiple ways to solve this question. Like I've just created the DS table for ease of explaining, but the idea is a lot of people solve this question using the distance as d. But what you need to observe is that the distance is neither given in the question, it is neither nor used in the options. The options do not really have the distance in it. The question doesn't talk about it. That means, in simple terms, you can infer that the distance doesn't matter. I can take the distance between A and B to be anything. So I should not take the distance as D. If you take the distance as D, what will happen is, if you take the distance as D, this speed is 80, your time will be D by 80. And I don't want to be dealing with that. That's like a very unnecessarily complex calculation. You might say, Piyush, it's a simple thing, but I don't recommend you to do that because that's a wastage of your time. Why do you want to waste your time? So I will take, I know the speed is 80 here, 100 here. I'll take the distance as 400. Why? Because the moment I take the distance as 400 kilometers, this time automatically becomes 5 and this time automatically becomes 4. They become integers. Now, the moment I have integers to deal with, imagine if I had d by 80 and d by 100 to deal with, I'll have to do LCM, I'll have to do the calculations. It will be unnecessary complicated math. On the other hand, the moment I take 400 kilometers, it makes my math so very simple. I can simply add the integers and I have my speed as 800 by 9. And those of you who remember 8 by 9, the value of 8 by 9, for them, this is a very easy question. Like it's 0.8888 and like that. So you can just multiply this with 100 and you will get the answer as B. Okay, very, very simple thing. Very simple thing. If you use the right value of D, it makes a huge difference. You might say, Piyush, I just saved 20 seconds. But remember, this 20 seconds, 10 questions becomes 200 seconds, 3 plus minutes. That's gold, worth its value in gold in GMAT, basically. That could be the difference between you getting into a school versus not getting into a school. Okay. So every time I see a long question, I start doing a brute force method. If I'm not able to finish, then I think about smarter methods, how to get rid of this tendency. So yeah, this is a common thing. This is set pressure. Okay, the test puts you under pressure and you go off the record, like off your regular path. So I generally say that always strategize before you solve the question. So strategizing is very important, Manish, and you need to do that. Again, feel free to reach out to me. I can help you possibly understand a few more things around it. So if you want to schedule a call on my calendar, you can use this link to do the same. I'm more than happy to talk. And we can also help you understand how we can possibly help you in your GMAT score as well. So please feel free to reach out. But the main thing is to strategize before you solve. If it's a longer question, you need to do more strategizing. The more difficult the question, strategizing becomes even more critical, guys. Because if you strategize, you will automatically think of better methods and it save time. Whatever time you invest on strategizing, might end up saving twice of that also. Okay, so totally depends on the question, but yes, definitely that's the thing. Now let's look at this question, guys. Now you all have solved this. How can we solve this smarter? So obviously there is one way of solving this question, which is to kind of simply use the equation, create an equation around it, like work with like the different values which are given to us and work your way around it. Now let me do one thing actually. Let me actually solve it using the regular method first, and then I will solve it using a better method. Okay, guys? So let's learn both the things. So if I have to use the regular method, I know that the speed of Ross basically is x miles per hour. Okay, and I know the speed of Rachel is 4x. Okay, I know after driving for t minutes, Rachel stops. So t minutes is when Rachel is driving, and Ross drives for t plus 45 minutes. Okay, so that's the values that I know as per this question. So the distance traveled by Rachel would be 4x into t by 60, and the distance traveled by Ross would be x into t plus 45 by 60. I need to divide by 60 because I have taken x miles per hour and it's in per hour. So I have to convert it into hours also. And then I can obviously equate these two things, 4x into t by 60 with x times t plus 45 by 60 and solve the question from there as well. Okay, that's definitely one of the ways to go about doing this, and you will get the answer as 15. Okay, now you might say, Piyush, this is simple enough. I don't have to really do too many calculations. Why do I care about a better method? I'm teaching you that because again, like it will help you in not in this question, not only in this question, a lot of other questions also. In fact, when you get better at this logical method, which I'm going to talk about, it just doesn't help you solve this question faster. Many a times you can solve this question as you read the question also, if you can get to that level of skill. Obviously, I'm showing you today for the first time. This is all a disclaimer because a lot of people don't understand the impact of it just because it is shown for the to them for the first time. But when you apply it multiple times, you actually see the benefit of it, a lot of benefit of it. So let's understand a better method of doing this, a more logical method of doing this. So I see that x miles per hour is given. It's not there in the options at all. So I know that x miles don't matter. X doesn't matter. So one option is I can take value for x also if you want to, but I will not go on that route. What I see is that Ross speed, I'll say Ross versus Rachel. Speed, I'll say the ratio is 1:4. Okay, guys. Now again, I'm not teaching you. There's a lot of conceptual clarity required behind this. We don't have the time. This is again a disclaimer. Don't think that I'm teaching too fast. It's just that I can't teach the entire process, but I just want to share it with you guys. Many of you will understand it right away in this short period of time as well. Some of you might not. For those who don't, please understand. Generally, when I teach this in a very slow fashion. There's a lot of pre-work that we do before getting to this. Okay, so that's a disclaimer, and that's the disclaimer for a lot of other things that I'm going to tell you today. Okay, please bear that in mind. So speed is 1 and Rachel speed is 4 times that. Now, what you need to understand is that after Rachel has stopped, she has waited for 45 minutes. Okay. Now, when during that time, Ross is moving at the regular speed. Ross's regular speed, which is 1 or x or whatever you want to call it, 1x if you want to call it. Rachel covered a certain distance. So what is happening is that, let's say this is the point when they started. So Rachel covered this distance basically at, you can say that, let's say this is the point that they started. I'm just going to put the starting point a little behind, and let's call this as Ross's position at that point when Rachel stopped, and this is Rachel's position. So this entire leg, this gap that you see that Rachel has created happened because of the relative speed of Rachel. So the relative speed of Rachel is basically 3x. So she covered this distance at the speed of 3x. And the same distance now Ross covers at the speed of x in 45 minutes. Okay. So another concept that I can use is, since the distance is the same, the ratio of time is going to be in the inverse ratio of speed. So if you see the ratio of speed is 1:3, so the ratio of time should be 3:1. That means that Ross will take 3 times the time to cover this distance that Rachel did. Again, the gap is what I'm talking about. The relative gap or relative distance is what I'm talking about. So now I know this 3k is 45. So k is 15. So this k is also 15. So this is 1k. So that is your answer. Now again, this might look a little complicated to a lot of you that, okay, I don't know what's happening here. But if you have conceptual clarity, this is something which will be very simple for you. In fact, I remember I saw this question for the first time today when I was solving it for the first time. While reading this question itself, I was able to solve it. So by the time I come to the options, I had the answer. Because when I read the question, I said 4x is the speed, x is the speed, the relative speed at which Rachel is moving forward is 3x. So that gap has to be covered by Ross in 45 minutes. And since Ross speed is x, the ratio is 1:3. The reverse ratio is going to be 3:1, which means the time taken by Ross is thrice the time at which Rachel was creating that gap in the beginning. Okay, so that is all I needed to do. But for that, you need to have the conceptual clarity and you need to approach this time speed concept in a logical way rather than a mathematical way. Now, as I said, some of you might say, Piyush, the math is not too complex. I don't mind doing this. I'll do this. Totally your call. But yes, if you get better at this logical method, the more difficult the questions get, it will be even easier to apply it. And we will see some of it today itself as we move forward. Okay, so let's go to question number 6. Again, fairly straightforward question, not very complex. It asks us basically how many hours would it take machine X operating alone to fill the production lot if X alone takes 3 hours and Y alone takes, X alone takes 4 hours and Y, not alone, X works for 4 hours for some time and Y works for 3 hours and they can complete the entire thing. Okay. Now, obviously, if I need to kind of find how much time X alone will take, I need to first understand this information. So what I generally recommend is There are two ways to do a time and work question. One is you can assume the work as one, okay, and do one by something and one by something and work with that. As in one by x and one by y is what you can work with as the rate. But I don't recommend doing that because fractions are difficult to deal with. So I say if the rate is not known to you, you can just take the rate as x and y, for example. So I know in this case that 4x plus 3y is my total work. Now you can take the work as one, you can take the work as anything you want to write, but this is your total work. Now, if they're asking me how much time will x alone take to complete the work, basically, then I need to find the time for x to complete the work alone. That will be 4 divided by x's rate. Okay, and this is the work you can write as W. Okay, now obviously there's one equation given to me. I can't use this alone to solve the question. W anyway is there in the will get cancelled out, so I don't have to worry about that. Statement 1 tells me machine X produced 30 bottles per minute. But again, how many bottles are there in a lot? That is not like given. It doesn't matter. I don't only care about how many lots they are working on, like the entire lot. So this doesn't help us in any way. If I go to statement 2, it tells us that X produced twice as many bottles in 4 hours as Y produced in 3 hours. So I know that 4x is equal to 3y. Now using this, I can get this expression in form of x itself. I can write 8x is equal to w because 3x is nothing but 4x. I can replace that here and I will get 8x equal to w. So I'll get x is equal to w by 8 basically, or you can directly find the answer also if you want to. You can simply say w by x is equal to 8 and that is what you wanted to find and that's your answer. Okay, so straightforward question, not too complicated. You don't have to calculate, you just have to understand the concept and you can solve it. The idea is when you look at this question and you do the pre-analysis, I'll just remove this thing once. So if I have to do the pre-analysis, my pre-analysis should be that I get an equation in x and y. I can get an equation in x and y. If I can somehow get the rate of x, a relationship between the rate of x and rate of y, another equation or another relationship between that, that is good enough for me to answer the question. And that's what is given to you in statement 2. And that's why statement 2 is the correct answer and B is the correct option in this case. Okay, guys? Again, please pardon me. I'm going a little too fast here because there are 10 questions that we need to do and I want to keep it under 45 minutes to an hour. So yes, going a little fast because I want to spend more time on the harder questions as well. Okay, now let's get to this one. This is another interesting question. A lot of you might have done this using a regular method of using a distance speed timetable. Definitely you can do that. But again, I did this myself using the logical method that I was telling you about. I'm going to come to that. And that allowed me to solve this question in a minute very easily. Like just by reading, by the time I read, just another 10-15 seconds, I was able to solve this. But I'll come back to that in a bit because again, for some people, regular methods will be better. So I'll just first teach the regular method. So every day, Tom walks from his office to home via the same route, covering s feet at a speed of x feet per minute. So I know the distance is s and the speed is x feet per minute. Okay, so time obviously I can calculate. I'm just putting in the information in the table. Today he took a different route, ending up walking 10% more than he usually does. So he walked 1.1 of s. Okay, now his speed is x meters per minute. Now this is something which is you have to keep in mind. It's meters per minute. It is not given to you in feet per minute. That's something you have to register in your mind. Now the question is asking me what is the percentage change in the time he took today compared to a usual day. So we have to find this time and then compare the percentage change. So first things first, let's get the units in the same way. Okay, so it's 1 feet, 3.3 meters. So I'll write this as 0.3x meters per minute because 1 feet is 0.3 meters. So x feet will be 0.3x meters per minute. Okay. Now, there are two ways to go from here also, even using the regular method. One is you can see very clearly if you observe the question doesn't have x. The answer doesn't have s, doesn't have x either. So since it is independent of s and x, you can always take two values, one for x and one for s, which make your math much more simpler. Okay, you can always do that. Like for example, if I have to pick a value, I can pick x equal to 10 basically, and I can pick s is equal to 30 for that matter. Okay, I can do that. So if I pick that, This is 30. This becomes 0.3 multiplied by 10, which is 3. Now, you might think, why is Piyush taking 30 and 10? So I'm taking those numbers which will get me integers across the board. Okay, that's what I'm trying to take. Again, I can be even more smarter than this, to be honest. Like, I can take even better numbers than this. But yes, let's not over optimize either. So this is the way I can do this. So I'll get the time here as 10, and I'll get the time here as 3.3 overall, not 10. Yes, 10 and 3.3. So you can simply see that there is a reduction of 6.7 on the time, right? 6.7 on 10 multiplied by 100%, and that gives me 67% decrease as the correct answer. I hope that is clear to all of you guys. Anyone has any doubts on this, please ask me. Happy to take it up if it is possible to take it up in a short time. But I hope you guys understand. And that's what, again, awareness is. So if you notice, what levels of awareness did I show? Number one, very important, that I looked at the question and I told myself that there is no S, there is no X in this. I can use an option, any value of X, S and X to solve this. I could have done it mathematically by writing S by 0.3X and 1.1 S by X and then subtracted that. That is a very heavy algebraic manipulation. Now, if you get into doing it, you will be able to do it, but you'll spend possibly another extra 30 seconds to a minute, depending on how smart you are with algebraic calculations, and it will lead you nowhere. Like it's the same option, right? Same answer you'll get. So why do we spend that time? And these are the small, minute things that you need to identify. Like, and you cannot do this on the day of the test directly. Please understand that. You have to identify these things beforehand. When I work with my students, I made sure that I teach these skills to them across different topics. How then they be more smarter? You have to train yourself to do that. And you pick these numbers, you make your life so very simple. Okay? I hope all of you are clear with this. Anyone has any questions? I am seeing a radio silence in the chat. It's either going too intense, you guys are so deep into it that you are not able to ask any questions in the chat, or yeah, I'm just it's just going over your head. I hope it's the former. Yeah, so yeah, it is definitely intense. I'm trying to like cover a lot in a very short span of time. But yes, guys, definitely there is a lot of science behind all of this. You need to learn this process in a step-by-step fashion. I'm just exposing you to how you can think so that you can start thinking possibly in that direction. Okay, now let's take a look at this question in a slightly different way. So as I said, I use logic also to solve this question. So one thing that you have to understand is distance is equal to speed into time. So if distance is constant, speed is inversely proportional to time is what I can say. As in, if basically two people are having, like if you know the ratio of the speed of two people, the time taken for those two people will be inverse. Now, this concept, some of you might say, Piyush, how can I apply this concept here? The distance here is not constant. When every day Tom covers S feet, today he is covering 1.1 times S feet, right? So obviously, I understand it's not constant. But let me, for a second, what I did to myself, I generally do is, I said, okay, let me for a second assume that the distance is same. Okay, the distance is basically like same for a moment. Okay, I'll just take a question from, I think Raj is your name, quite time, right? I'm clear with these concepts and great explanation, by the way, but the biggest issue is that I tend to get confused with the clock. Yeah, so Raj, it's important that you need to kind of apply this on a regular basis. Like I remember one of my student, Keshav, really great guy. He was very smart at quant, just like you also came second in the quiz today, so I'm assuming you're really good at it. But he was not able to consistently use the method, something similar to what you are talking about. But we worked together. I helped him understand how you can think, because see, right now I'm just showing what are the different methods, but how do you decide, what is the decision metrics in place, that how do you decide when to do this, when to do that? That is also an art that needs to be learned. So we worked together for about 30 days, we perfected the art, and this guy improved his score to 705, got a quant 88. If you want to check out his interview, do check it out. There's some key learnings you get from this. This guy was rejected by some of the best schools. Like he applied to a lot of these schools, around 10 plus schools in round one, because of slightly lower GMAT, and improved his score to 705 and got accepted to Michigan Ross and even Yale. So got scholarships also from some of these schools. Even a lot of other schools he got into. So the idea is that The main thing you have to also understand is what and why and when. When can you apply this? When you can't apply this, and all of that. So there's a proper process behind it. So important that you apply that learning, learn that before the test. You cannot really go in the test and try 10 different things in that time. Obviously, there's a lot of things that needs to be done before that. I hope that answers your question. Okay. So yeah, so let's focus on this one. I'm coming back to it. So for a moment, I'm just keeping, Stalin, I'll also come to you. For a moment, I'm just keeping it on the side that the distance is different. Had the distance been the same, what happens? Let's understand that. Now, I see that the speed ratio, again, I don't have the DST table here. I'll just frame it once again. So I have the speed on a regular day. Okay, let me actually, yeah, let me give it this one. So the speed is 0.3 x on a regular day, and x, again, I'm writing in meters per minute. Okay, I'm just doing the unit conversion. So if I see, I can write this as the speed ratio here is 3:10. Right, guys? Understand that. The speed ratio here is 3:10. Those of you who know how to find the ratio will be able to do it. It's a very simple thing, pretty easy to do it. So 3/10 is the ratio of the speed. Now, if 3/10 is the ratio of the speed, and I assume that the distance is same, then the time ratio should have been 10:3. Correct? Now, if the time ratio is 10:3, that means time had reduced by 7. 7 over 10, that means 70% decrease in time. Okay, and understand, guys, I am able to do all of this as I read the question. I didn't have to put pen to paper. I'm just doing this to help you understand this. I know it's heavy, but again, I have limited time. But I'm trying my best to do that. So I was able to do this by reading 3:10 is the speed ratio. Time ratio is 10:3. So there's a 70% decrease in time. I looked at my choices. I said that the distance has just increased by 10%. And again, there's another important concept in the math part, which is how much approximation is correct approximation. That is another thing that I also teach my students. So 10% is something I have to adjust to. But if you look at the decrease, there are 3 options with decrease. So answer has to be between these 3 for sure, right? And the choices are pretty far away. So far away that I don't have to worry. I know that my answer is C. You might say I'm taking a I'm taking a risk, but it's a very calculated risk. I know my answer is going to be very close to 70, and I can even identify on which side of 70 it can be. But I don't need to. I don't need to, simply because the question options are pretty far away. And this you will find in many GMAT questions. There are a lot of GMAT questions that you can just solve with options. You don't have to do anything else apart from. Okay. Okay, good, Samriddhi, you guessed, but it's important that you take calculated guesses. What I did is not calculated guess, it's a calculated risk I have taken, and I know my chance of getting it right is almost 100%. That close. Okay, but yes, guys, please understand, I don't want you to use this method if it is not working for you. When I work with students, I make sure that I look at the student's capability, how he's learning, and the same student can have different responsiveness to 2 different methods. In one case, he can learn a smart method faster. In another topic, he might not. So it's important that you adjust to it. I'm not married to the idea of using this method only. Okay, please understand. And that's why I gave you another method. The regular method, if you remember, it was just on the previous slide, where you can be a little more smarter by assuming S and X by observing that the options don't have them. You can always use that. But there is a merit to using this method depending on which skill level you are at as well. Okay, but please make sure that you don't blindly start applying that. Okay, you know what, I'll just apply this method. You have to get to a certain skill level to do that. Okay, now all these disclaimers are necessary. So coming back to this, so as you can see, we are seeing conceptual clarity. Understanding distance is constant means speed is inversely proportional to time, or time is inversely proportional to speed. This can actually help you solve many of these questions faster. This is what I mean by conceptual clarity. Just knowing the formula is not sufficient. If you have conceptual clarity, you will get a higher quant score. Logical methods, smarter methods, yeah, using the method of ratios to solve questions. We just use ratio method to solve distance, speed, time question. That's a smarter method is what I'm talking about. And there is another smarter method where you take rate as an integer. We talked about that in time and work. You take work as LCM. Okay, that's what you can do, and that's a smarter method. Awareness is when you take S as 30 and X as what did we take X as? Did we take it 10? I think, yeah. need to access 10. So awareness is that you look at the options, you see, okay, S and X are not there, D is not there. I don't care which numbers we use. They are not in the options. That means they get cancelled out. So I can take any number. That's what awareness is. Awareness is about looking at options, how far away they are, and then working at it. And please understand, guys, I'm not advocating that you should be blindly guessing the question. That's very wrong. Okay, that would be like going. That's as good as you go unprepared in the test and you just blindly guess everything. I'm talking about smart work. Okay, guys, not guesswork. Calculated risk is what I took. Less than 0.01% chance of getting it wrong. So you have to mix everything up. It's that mixture that gets you that score. Basically, all those things are very, very critical, and all the blend is what gets you the score. Okay, now coming to this question. Question number 8. We are already at 40 minutes. So, but yes, I'll try keeping slow. I'm trying to explain the process as much as possible in the important questions. So, but let's do this. So I know there is E, there is D. They're painting a wall. Emma starts painting and work for 3 hours. So time that she used to work for is 3 hours, basically. D painted the rest of the wall for 4 hours. Sam alone, okay, Sam is a separate person. He can do the entire work. Okay, so work in this case is the total work. In this case, it's a partial work. Okay, I'll just write down partial work. So this guy can do entire work in 4.5 hours. Okay, now one thing which I recommend to use, like my students to use, and again, I'm not solving this using the regular method. Regular method is to take work as 1, and you can take the rate as 1 by 4.5 and do all the math that you want to. But I'm just going to use a better method for you to learn and apply possibly. And when I use this method, let me give you a disclaimer. This method can be used across entire time work question bank. Like all the time work questions can be solved using this method. It's not only for specific questions. You just have to master this to a different degree. Okay, and it makes sense to do that because it helps you save at least 1 and even in many cases 2+ minutes on every time and work question. So let's go to this. So what I will do is I'll take the work as the multiple of this thing. I'll take the work as 9. Okay, 9 units. Okay, I assume that is an assumption that I'm making. Why am I doing that? Because that allows me to get the rate of what this guy's name was, Sam, not same, Sam, as 2 units per hour, right? Because he does 9 units of work in 4.5 hours. So it's 2 units per hour that he is actually working at. Now the question is asking me, how much time does it take to paint the wall if Emma and D work together? So again, I don't know the rates of these people, so I'll just take them as E and D. So I know from this that they together completed the entire work. That means 3E plus 4D is 9, right? That's the total work. I've assumed total work as 9 units. That's one assumption. That's one equation that I have with me. Okay, and I know Sam's rate is 2. Right? That is what I've gotten through my assumption. Okay. Now, if I want to solve this, I want to understand how much time will this guys take to complete the work. I need to find the sum of their rates. I need to find the sum of their rates because if I have the value of E plus D as, let's say, I'm just taking a random number. If it was 3, for example, I will get the time as 9 by 3, which is 3 hours, right? So I need to find the sum E and D. That I can find if I have another equation in E and D, because I have this equation from the question itself. Okay, this is there in the question. Now, with that information, I'm going to go to my statements, and the pre-analysis is very critical. So if I look at the first statement, it says Emma, Sam, and D together can finish the wall in 2 hours. That means if I multiply 2 with the rate of Emma, Sam, and D, I should get my work. And I know from this, I already know the value of Sam's rate is 2. So if I solve this, I can get the value of E plus D, and that is sufficient for me to answer the question. So this is something which I can use to solve the question very easily. I don't have to calculate any further because this is a DS question. If I go to statement 2, it says, in 4 hours, D painted twice the area as Emma did in 3 hours. So I know that in 4 hours, the work done by D is 4D. That is basically 2 times the work done by Emma in 3 hours. Now, this equation will get me a relationship between E and D, which I can then plug back in this particular equation and get the value of E as well as D. And that will suffice in order to answer this question. So basically, both statements, sorry, each statement alone is sufficient. So answer in this case is going to be D. Okay, guys, and again, you don't need to solve. You just need to have this logical understanding. Again, please understand whatever I've written here is to basically help you understand what is happening behind the scenes. But technically, if you understand, you have conceptual clarity, you will not need to write any of this also. In most of the cases, you'll be able to logically reason how much information is required. And that's the best part about data sufficiency. And that is one thing, if you really do well, you can actually gain a lot of advantage, especially in DI, because in DI, DS is something which can help you save a lot of time, which you can use for the more complicated questions like TPA, MSR, and all. And the only way you can actually save that time in DS is by being more logical. Okay, and for that logic to play its part, you need to have a very good conceptual clarity and also use better methods. Okay, now let's go to question number 9. This is one of the questions which is slightly more calculation intensive. I cannot apply the concept of relative speed here. In this question, this is a very good example of knowing when you cannot use smarter methods, because obviously here it's saying that what is the ratio of 2 times. One time is when the distance covered by one of the trains is 1/3 of the other, and the distance covered by the other train is the same train is 3 times of the other. So I cannot use relative speed here. The distance is not the same. I can't use any of those smarter methods. I'll have to resort to using the regular method of solving the question itself. Okay, so that's what we have to do in this question. There is no other way to do this. So if I write down the equations properly, I know that train 1 basically left the station at 1:30 p.m. and it was running at 30 miles per hour. And train 2 left the station at 2 p.m. and it was running at 100 miles per hour. Okay, so then it asks me, first is the time that it took for train 2 to cover 1/3 the distance train 1 did. Okay, so train 2, if I take the time as T1, will cover 100 into T1. Okay, that is the time distance it covers in T1 time. That is 1/3 of the time, distance that T1 covered. Now T1 is covering the distance as 30 T1. Okay, that is the time that it takes to cover the distance 30 T1, plus it is actually having a certain advantage over T2 because it has started 30 minutes early. Now please understand, I'm taking T1 from this reference frame, which is 2 p.m. Okay, I'm taking the reference frame as 2 p.m. Okay, so if I look at that, then I have to add 15 to this, because in half an hour T1 will cover 15 miles distance. So this, if I solve, I will get the value of T1 from here, or a certain expression I'll get. The second time will be T2, let's say. So I'll have to write 100 times T2 is 3 times 30 T2 plus 50, basically. Okay, so I have to solve both of these to get my answer. So if I do the first one, I get 10 T1 plus 15. So I'll get 90 T1 from here as 15, basically, and which will give me T1 as 1/6, basically. From here, if I solve this, I'll get 100 T2 is equal to 90 T2 plus 45. So from here, 10 times T2 is 4.5 and T2 is 0.45, basically. Okay, and I need to find the ratio of T1 by T2, which is 1/6 divided by 0.45. And if you do the math, you'll get 1:81 as your answer. And in fact, you don't need to do the entire math also. You can see the options and definitely be smart here also, that the answer is going to be very, very small. It's going to be smaller than 1/80 also. So that is also something you can do, but that's the way to kind of solve this particular question. Okay, so no smarter methods can be used here. And that's another art, as I was telling earlier, that is also something that you need to also learn, basically, where you can't use that. So that's the piece. Now, coming to this particular question. Now, this is a very interesting question. This is based on another official question which was on similar lines, based on time and work. Now, there are multiple ways to do this question. Again, one way is I can say Karen, Foggy, work, rate, time, Karen plus Foggy. So I take the work as 1, and time that Karen takes is 4 hours less than Foggy. So if Foggy takes 4 hours, T hours, Karen takes T minus 4, basically. So rate of Karen will be 1 minus t by 4, 1 by t minus 4, and 1 by t here. Now they complete 62.5%. So it's 0.625, or you can write it as 5 by 8 is what I would recommend. 5 by 8 of the work in 3 hours. Okay. So their total time, the rate would be, in this case, if I want to calculate it, will be 5 by 24. 5 by 8 divided by 3. Okay. So I know that 1 by t minus 4 plus 1 by t is 5 by 24. And using this, you'll get a quadratic equation and you can solve for t, and t will come out to be, basically in this case, t comes out to be 12, basically. And the question is asking you how much time will Foggy take to complete 50% of the task. So that will be 6 from this, basically. Okay. But again, there's a quadratic equation that you'll have to solve. So if you're comfortable doing that, you can do it this way. This is one of the ways of solving this question. Okay. Do I recommend it? Totally up to you. Like some people are really good at this. They can do this fast. I recommend it to them to do it this way. But if anyone has a doubt in this right now, please ask me, because I'm going to delete this explanation in like another 30 seconds or so. So some people are really good at using one as verb. I recommend them to use this. Some people are more logical. So for them, I recommend them to use a LCM method or a more logical method of solving this question, which you might think requires a lot more thinking. But as I said, if you're new to it, it will require a lot more thinking. If you're used to it, it just is very, very smooth. It's extremely smooth to use that method. Okay, I'm gonna take a shot at teaching you that. There are some changes required to the question before I use that. Okay, and that you'll have to do obviously in the test, and it's easy to do. Don't worry. Okay, but there's no question, no doubt on this. I'm gonna rub this now, guys. I can't bring it back. So I hope this was clear. You have to solve this quadratic and get the answer. But what I would first do it. See, there are a lot of things happening here. They have asked for 62.5%. They said, oh sorry, they said 62.5% is completed in 3 hours. So if they are doing 62.5% in 3 hours, I'll convert this to completing the task in 4.8 hours, basically. If they do 5/8 of the work, and Natasha, that's what I'm coming to, LCM method. 5/8 of the work in 3 hours, you can just do 3 multiplied by 8 by 5, and you will get that the complete work is done in 4.8 hours. The second thing which I will change is, I don't want to see Foggy's 50% time. I will change it to Foggy's total time. How much time will Foggy take to complete the entire work? Then I'll have to multiply each of these options by 2, right? Because the time given is for half of the job. Okay. So if I change my question, if I make these 2 changes to my question, this is what the question becomes now. Okay. Because that's what they wanted to give. But they just disguised it a little bit so that you can't use the LCM method that easily. Now, using the LCM method here wouldn't be very straightforward, but still is possible to do. Let's try it out. So K, F, and K plus F is what we have. Okay. So work is there, rate is there, time is there. Now I know the time for them together is 4.8. Okay. If I take the time taken by Foggy to be T, again, I'm not taking a variable, I'm just explaining you to guys for a moment, then this is T minus 4. Now, one more thing you need to understand is that the value, the time taken by any one of them to complete the job will always be more than the time taken by both of them together to complete the job. Is that clear? So I can say for sure that T is greater than 4.8 and even T minus 4 is greater than 4.8. That means T is definitely greater than 8.8. And the question is asking me for T. Okay. So the answer is basically in the form of T over here. Sorry. Just a second. Yeah. Just a second, guys. I just have to check if I have copied the question right. Yeah, my bad, guys. This is not 8. 2 times 6 is 12, right? So let's just get that back. So this is yeah. So this is 12, okay? It was 6. So 2 times of that is 6. Yes, thank you so much, Yasha. That's what I was trying to see, basically. So it's 12. Now, I know that T has to be greater than 8.8. Okay? Question is asking me for T. Definitely A is not the answer. Okay. Now, I have 2 choices in front of me. I can eliminate one choice. I remember the official question on which we have based this question. There, Just because by drawing this inference that I've drawn, t greater than what? Just with this inference, you could knock out three choices. They were just out like that. And you had just two choices remaining. So whatever I'm gonna do next was very simple then, because I had to just do that for one of the options. I have to use that one of the options. If that gives me the answer, if that matches with the solution, matches with the numbers, then that's my answer. Otherwise, the other one was the answer. So that is the official question. Obviously, in this quiz, we can't do official questions. That's why I am not able to show you that one. Otherwise, I would have shown you the exact question. But three choices are out. This is slightly more difficult. We have kept the other choices like that, but one choice is still out. Now, I have two choices in front of me. I can use the regular method, assume work as one, do one by whatever, whatever, and solve it from there. Or I can use the LCM method. Now, how do I use the LCM method? I don't have, in the LCM method, we need to have time, right? Whose LCM we need to take. Here, we don't have that. But we do have the options with us. So for a moment, if I assume that B is the correct answer, okay, then I will write this is 12 and the time taken by Karen alone is 8, correct? Now, if that is the case, what I will do is I will see if with this assumption, this is what I'm assuming, guys, okay? I have assumed this. I've taken option B for a moment. I'm just fitting it and checking whether it works, okay? And if the final result for the time taken by both of them comes out to be 4.8, then it is validated. Then it is validated that this is the right assumption, this is the right answer. That's how you need to think. Okay. I know I'm being a little fast here. Again, apologies for that, but I'm trying my best to explain in a short period. So if I have the rate, time as 8 and 12, I should assume the work as the LCM of these two, which is 24. So if I assume the work as 24, then in this case, the rate of K will be 24 by 8, which is 3, and the rate of F will be 24 by 12, which is 2. Now, this LCM method, those of you who want to learn it, we have taught it in our GMAT Quiz coursework as well, in very detailed fashion. You can go through it. We also teach it in our private tutoring, one-on-one tutoring classes, basically. Okay, so the rate combined would be 5. So if the combined rate is 5, 24 is the work, the time would be for K and F, the time would be 4.8, which is matching with the correct time. That means my assumption was correct, and that is my correct answer. That is my correct answer. Okay, not 12, but 6, which is half of it. Okay, see how simple it became. Now you might ask me, Piyush, here your first option worked. Yes, I understand it worked. But if you're really good at LCM method, trust me, even if you have to try 2 or 3 choices, here maximum I have to try 3, right? 12, 16, 18, 24, 20, 16, 18. If none of them are right, 24 is right for sure. But if I'm very good at it, it will hardly take me 10 to 15 seconds to check for each of these, or maximum 20 seconds. And if you frame the quadratic equation, that will definitely take you longer. And there is more chance of error in a quadratic equation while solving a quadratic equation. Again, that is, I am adding a disclaimer. This is all subjective, depends on the student. A student who is more logical at solving questions will work better with this method. A student who is mathematically better, like algebra is better, they can probably solve this quadratic equation. But why am I teaching you this method is not just because I want you to understand how to solve a time and distance, time and work question. These methods are important for a lot of other questions. Like we are doing a lot of other sessions also on this topic, different topics, sorry. So we're covering a lot of other methods as well, but you need to develop this mindset if you really want to get to a high, very high quant score. Okay, guys. So summarizing the entire discussion, it still went to an hour. I wanted to keep it shorter than that. Learning the right methods is the key. Some of these methods, again, I've shown you. Some of these methods I've written on the screen. But in case you want to obviously learn more about it, feel free to reach out to us on our details. I've shared it on the screen as well. But yes, if you have any other questions, guys, I'm going to take up your questions for a couple of minutes. If you have any questions, feel free to ask me right now. Open-ended questions also, not necessarily just related to the questions that we did today. So feel free to ask me. I'm more than happy to take it up. But if you want help from our side, learn some of these methods and become better at quant, maybe get to a quant 90, who knows, feel free to reach out to us on this link. I have shared the link to block out time on my calendar. And also stay tuned. In the meantime, you ask your questions. I'm going to just announce something important also. This Friday, we are interviewing one of our students who improved his score from a 605 to 695 in a matter of 30 days. Okay. So stay tuned this Friday. It will be on the GMAT Club, the same YouTube channel. Roshan, this guy improved his score across the three areas, 5 points in verbal, 5 points in quant, and 4 points in data insight. So if you want to get inspired and understand how can you improve your score before round one, do attend this session, debrief session that will happen on the Friday. Okay? But yes, any other questions you guys have, I'm going to be here for a couple of minutes. And I tried my best to give you as much learning as possible. It was a very short session. I tried my best. 10 questions are just too much to do, but I hope I did some justice and you guys ended up learning some great things so late in the night. That was Sunday night. I know how each of your weekends are with the GMAT, but I hope these methods will help you wrap up your GMAT journey sooner and enjoy your Saturdays and Sundays again. Hopefully. So yeah, any other questions you have, just feel free to share them with me. More than happy to kind of take them up, guys. Okay, I don't see any other questions. I hope I was able to explain it really well. I tried to like squeeze in a lot today. So yes, please feel free to go through this recording. Again, this recording will be available on GMAT Club channel. So some of this, if you go through once again, possibly you'll be able to pick up much better. And as I said, there's a lot of pre-work required for some of these methods. Do learn them. I didn't want you to just see the generic solutions using run-of-the-mill methods that you'll find possibly everywhere, even on GMAT Club. I just tried to kind of add as much value as I could in the session. I felt that anyone who is attending this should get more value out of it than just seeing the regular solutions. So I've just tried my best. Thank you so much, Raj. Thank you so much, Samriti. Happy to hear that you found the session helpful. Thank you so much. But yes, guys, I don't see any questions, so I'm going to end the session now. But feel free to reach out to me, guys. Again, my contact details are here. And feel free to schedule a call on my calendar if you want to understand how we can take you to your dream score. And who knows, we could be interviewing you really soon on the same channel. Thank you. All the best, guys. And please feel free to ask any other questions that you have on the email ID or my WhatsApp. Thank you, guys. Take care. Bye-bye.